Hello. Well, Dick has been bugging me because he says that I'm not doing these tests properly. He points out that pumping air into the box is the opposite of an IP67 test because it establishes an overpressure in the box rather than an underpressure, something which I had actually mentioned in the video. But he's quite right about that. But of course, remember that before we did that air pressure test, the box had actually failed a test when I heated it up and put it underwater, and that did not apply any kind of overpressure. So the thing failed anyway. But the question is, did the box fail, or was it the connectors that failed? That I've established that both actually fail with the air pressure test, but we're still uncertain as to whether, if we just put them underwater, the box would fail by itself. So what I've done here is, this is the box that I had. I've taken all the connectors off it and put some duct tape round on the inside and the outside to block up the holes, I hope. By the way, nothing will persuade me that this box design is satisfactory, because I don't know if you can see that, but there's a very, very clear bow when you do up both of these things, which is just a really diabolical mistake. But nevertheless, so we can test that. This wheelie bin is just short of 1 meter deep, so I'm going to fill it up with water after putting these two things inside it. This box here is another box. It's the only other box I can find. This box here is the only other box I can find that's approximately the same size, although it's not quite so tall, or the depth, or whatever you like to call it. And it has this weird fixing mechanism which doesn't rely upon screws, it just relies upon a clip. Well, that's an advantage in one respect, because it means I can't over tighten it. It tightens to a specified thickness, and I don't observe any bowing along here, which is nice. So I thought, this box is brand new. It's also IP68. This is IP67, this is IP68. But I'll put them both in the wheelie bin, and then if I can find a hose, we'll put some water in. There's the bottom of the wheelie bin. There's the top, which is 0.978 meters. Near as damn it, 0.9 meters. Right, there are the two boxes at the bottom with an engineering brick on top of each. I think that should be enough to hold it down. Well, you may be wondering why I've got 50 meters of garden hose in my kitchen. Well, that's because I was using the hose to wash off the snow off my cars, and eventually it froze up, so I brought it in to thaw out. Anyway, we've got a thaw coming on now, so I can safely take it outside again. Right, on with the water. I hope these bricks are heavy enough. Well, actually, one of them wasn't, so we need 2 more bricks. Right, we've got 2 engineering bricks on top of each box now. I'm just thinking, a slight problem with this test is that we've got 2 engineering bricks sat on top of the lids of these 2 boxes. So they are exerting a downward force on the lid, additional to any force exerted by the screws and clips that are holding the lid in place, that's a bit of a nuisance. Possibly what I should have done is screwed the boxes to a piece of wood and then put the bricks on the piece of wood, so that the boxes were unencumbered by anything. Anyway, we've nearly got to the top, the water to the top now, so I'll continue with this and we'll see what happens. Well, here's the electric gate at the entrance to my drive, and this box is one that I installed about a year ago. It's got a button on it. The last push button switch rusted to nothing, so I got this nice IP68 box and installed it, and I put a couple of silica gel things in there. You can see how damp they are. and you can see just by looking at the dirtiness of this seal is it obviously hasn't been sealing satisfactory all the way around, has it? And look at the contents of the box, and then look at this connector, which is clearly rusting to buggery. But clearly this seal was not effective. Perhaps the most effective bit of it was the silicone sealant that I put around here. That seems to have worked. But this is just another example of an IP68 box that doesn't work. I've got some fresh silica gel that I'm going to put in here, which I regenerated earlier on, and we'll do it up again. But it's obviously going to fail shortly, isn't it? Actually, to be honest, this is IP65. I've just seen that. It says IP65 upside down there. Okay, so it's not IP68, but on the other hand, we haven't got it a metre underwater, have we? We've just got it outside where it might rain. And the mystery to me is why so many people who design supposedly waterproof boxes are morons. Why don't they get somebody sensible to design a box? It's easy to do it correctly. I don't know. The world is mad. Well, I think that's full now. Yeah, it's definitely full. And they're still down there. And still, okay, no bubbles coming out, as I can see. So we'll leave that there for 24 hours and see what happens. Just looking at the Wikipedia entry for these IP codes, IP67, immersion up to 1 meter's depth. Ingress of water in harmful quantity shall not be possible. Test duration 30 minutes. Well, I'm using a much longer duration than that, but you notice the weasel words, ingress of water in harmful quantity. Well, any ingress of water is harmful to electronics. Even just water vapour coming in is harmful to electronics because it starts corrosion, doesn't it? Then we have IP68, immersion 1 metre or more depth. Equipment is suitable for continuous immersion in water under conditions which we specified by the manufacturer. However, with certain types of equipment, it can mean that water can enter, but only in such a manner that it produces no harmful effects. Well, that's a damn fool get out of jail card, isn't it? That's typical of the kind of garbage manufacturers write into standards so that they can say they comply with the standards when they don't in fact do anything. I don't know how they can be so mental. Well, the Fibox Euronord box, which is the one that I put holes in, that one we know is IP67, but I'm uncertain now as to what this new box that I'm also testing is, because if we look at the RS Components place where I bought it from, it says IP68, but then if I look at the data sheet that they also provide, it says protection class IP67, higher protection on request. So that's a little bit uncertain, but anyway, it's IP67, it might be IP68. I shall have to inquire from RS Components, and we'll see what happens. Well, I started this test at 4 PM yesterday, and it's now just past 10 AM the next day, so that's 18 hours it's been underwater. There's nothing obviously different down there. I do have an electric pump, but I'm thinking it's a bit too much bother to rig it up, so I think I'll just use a bucket to empty this water out. I could push it over, this whole thing over, but I don't want to do that because I don't want to disturb these boxes. Right, that's done that. I think I can just reach up. Right, well, annoyingly, or rather maybe successfully, there doesn't seem to be any water in that, despite its bowed lid. Actually, the lid is less bowed than it was before, perhaps because as a result of putting engineering bricks on top of it. That one looks all right too. I'll take them inside and dry them off. Well, I've undid the screws on the firebox box, and the lid will not come off yet because air pressure is holding it in, which proves that it's gas tight as well. I think I can just get a screwdriver in here and lever it up. Presumably when I plunged it into the water it cooled down and therefore created a slight underpressure. Yeah, there we go. Well, that's completely dry in there. What about this one? Can't see any water in there. There may be some water in this clip, but that's not relevant. Yeah, that's completely dry too. Well, so that's good news. Up to a point. Well, what have I learnt from this test? Firstly, it seems that the boxes aren't leaking when they don't have holes in them and don't have connectors in them. So Dick was right. He's nearly always right. It's so annoying. Secondly, you know, when I took the firebox box out of the wheelie bin, the lid didn't seem to be bowed, and I thought, well, maybe that's because I put engineering bricks on it for 18 hours. No, that was not the case. The thing that was stopping the bowing was the underpressure inside the box. The minute I tried afterwards, I put the lid back on after I'd opened it, and it was bowed again. So that raises the question, if there had not been an underpressure in the box, might it have leaked? Another problem I have is that the IP6 code is not completely cumulative. If you've got an IP66 box, you can be assured that it complies with IP65. But if you've got an IP67 box, it doesn't necessarily comply with IP66. And if you've got an IP68 box, it doesn't necessarily comply with IP66. Now the problem with that is that 65 and 66 relate to resistance to water jets being squirted at the box, and 67 and 68 relate to the box being put underwater. We actually need protection against both of those things. So there seems to be no alternative but to buy different boxes and test them under all conditions and come to one's own conclusions. What I really want is a gas-tight box which is either sufficiently strong to accommodate changes in pressure caused by changes in ambient temperature, or is sufficiently flexible to accommodate such changes in pressure. I'm a bit nervous of boxes which change their shape according to the pressure inside, because it makes one wonder whether they're going to perform satisfactorily under all circumstances. They're likely to be quite large ambient variations of a box that's on the deck of a ship in the Atlantic, or a boat I should say. I know that there are people who say they have vents which will pass air but will not pass water vapour, but quite frankly I don't believe them. I'm not prepared to risk that. I want a gas-type box. Third thing that's worrying me is there definitely seemed to be a leak around the cable seal on the Lumberg connector plugs. If I can't reliably seal a cable to a connector, that's a really serious problem, because I need these connectors, otherwise everything has got to be soldered up in situ and all the electronics are going to be stuck on the boat forever, and that would be really awkward for any kind of development work. So, well, maybe that's why Ondrej controls his whole electronics via Bluetooth, so you can seal them up and just reprogram the thing in situ without even opening the box. That's one advantage. But what if you wanted to change the electronics? I suppose I could design the whole thing so that the electronics plugs into the box and everything else is permanently wired up without any connectors. That would be a way around it. Anyway, that's where I am on waterproofing. And you know, before I started these waterproofing tests, I had some kit that we could have taken onto a lake and tested the boat, and now I've got nothing. So I'm going backwards at the speed of light at the moment. It's quite disappointing. Anyway, thanks for watching.